Assalamualaikum and hello. In this video, we are going to learn about the rate law. Let's proceed. In rate law, there are two important terms that you have to know. The first one is rate constant, which is constant of proportionality between reaction rate and concentration of reactants. Please take a look. We only focus for the reactants sahaja untuk rate constant. The second term adalah order of reaction. So order of reaction is the sum of the powers to which all reactant concentrations appearing in the rate law are raised. So it means that the value of X and Y must be determined experimentally. So what does it mean by unknown X and Y? Itu yang kita akan faham dalam bahagian rate law. So rate law ataupun another name for it is rate equation is an equation that relates to the rate of reaction to the rate constant K and concentration of reactants raised to some powers. So that some powers we are going to determine and set them as unknown. So that's why we are going to express as unknown X and Y. For example, I got this equation as general. If you know that rate is directly proportional to the concentration of reactants, so you know that if the rate increases, the concentration of reactants also increases. Same as well for this case, kita ada reactant A and reactant B. So of course, rate is directly proportional to the concentration A times with concentration B. So how you want to make it this symbol directly proportional into an equation? So we are going to replace it with equals to. So once you put the equal sign, there must be a constant in front of your concentration. So that's why that constant kita akan letak sebagai rate constant. The symbol is K. And then times with concentration A raised up to the power X times with concentration B raised up to the power Y. So this X and Y adalah order of reaction respect to that reactant. Dan inilah yang kita akan tentukan dalam rate law. And in order for you to determine the overall order of reaction, maknanya dia adalah hasil tambah X dan Y. Dan as usual, K is called as rate constant. So itu benda pertama yang awak perlu faham, how you want to write the expression for rate law. It's totally different from what you've learned in the previous video where you learn how to write the expression for differential rate equation. But in this case, we are going to learn about expression for rate law. So I hope you clear until this point. The next one, we are going to use this expression for the rate law and make sure you got the subject rate equals to at the front. You know that K, rate constant, relates to the rate equation to the concentration of reactants. And of course, you see here in my expression, I only put for the reactants sahaja. C and D adalah saya punya produk. They are not considered in rate law. And the next one, if you got the larger value of K, of course, the reaction will proceed very fast. So based on your expression from here, you know that the value of X and Y can only be determined experimentally. So there must be the value for them. And you have to determine that one. So X and Y is what we call order of reaction. So this is what I'm going to focus next. What is the order of reaction? So order of reaction is usually defined in terms of reactants concentration. So maknanya dia akan jadi power of that reactants concentration. So the order of reaction is not related to the stoichiometric coefficient for the reactants in balanced chemical equation. For example, you got this equation, so you already balance all of those, And when the rate law is given, you see this is the expression for the rate law. However, you see that the concentration for F2 and the concentration for ClO2 raise up to the power of 1. And I want you to focus here. ClO2, when you balance the equation, you got the coefficient 2 in front of it. But in the rate law expression, the order of reaction with respect to ClO2 is 1. So this is what I'm going to focus for you. They are not the same. So please remember that. Now, we are going to learn how to determine the order of reaction based on rate law. You got this expression. This is very simple because I give you the expression for the rate law. So, it's very easy for you to determine the order of reaction based on each species. So, let's go to determine the order of reaction with respect to NO. As you see here, you got power of 2. So the order is going to be 2. Please write it as number. If you write it like this is wrong. Don't write in words because the order of reaction is a value. And then next one, you got the order of reaction with respect to O2. The value will be 1 because it will raise up to power 1. So if I want you to calculate the overall order of reaction, is going to be 2 plus 1. The overall order is 3. So that's for the question A. Next one, we got question B and question C. Let's go one by one. So for question B, I want you to determine the order of reaction with respect to CH3CHO. So you see from here, it's in the form of fraction. So don't worry about that. Just put the value as you see from this rate law expression, 3 over 2. And overall order of reaction will be 3 over 2 as well. Why only one species happen in this expression? Because we just focus for the reactant sahaja. Okay, let's continue with the next one. I got another expression for question C. As you see here, my rate law expression is this one. So how you want to determine the order of reaction with respect to H2O2? You see here, kalau tak ada nombor, maknanya dia power of 1. So the order of reaction with respect to H2O2 is 1. The next one, the order of reaction with respect to I minus, also 1. And the next one, the order of reaction with respect to H plus. As you see here, H plus is being considered as your reactant. But you see from the expression of rate law, the species H plus tiada dalam expression. We know that the concentration of H plus is to the power of 0 because the value will be 1. Anything to the power of 0 will be 1. So that's why order of reaction with respect to H plus adalah 0. So overall order of reaction adalah hasil tambah semua iaitu equals to 2. So please be careful, especially untuk species yang tidak ditulis dalam rate law. Sebenarnya dia ada, cuma kita tak tulis sebab nilai concentration itu adalah 1. Same case with H plus. So Miss harap you understood about this one. Let's try the last example, which is example 1. So this is my question, and I want you to answer question A, write the rate law for the reaction, and question B, calculate the rate constant for the reaction. So how you want to determine the rate law for this reaction? You see from here, this statement, the order of reaction is first order reaction with respect to NO2 gas. Your NO2 gas is your reactant. So when you want to write the rate law, we just consider the reactant sahaja. So that's why my rate law is going to be rate equals to K times with concentration NO2 to the power of 1. Tapi saya tak tunjuk lah. So, this is my answer for the expression of rate law. The next question, it asks you to calculate the rate constant for the reaction. So it means that you have to determine the value for K. So how you want to determine this one? You have to rearrange the formula. So K is going to be the subject equals to rate over concentration NO2. And from the question given, the initial rate for the reaction is 1.5 exponent negative 2 molar per second. So this is for the rate. And then you got the concentration for NO2, 0.2 molar. So just insert those values. You will get the final value for the rate constant is 0.0750 per second. How this happened? Because molar here already cancel out each other. So yang tinggal hanyalah per second. So that's why this is going to be the units for the rate constant. So I leave it to you. Try this 4.0 for you to enhance your understanding based on rate law expression in this video. For the next one, I'm going to explain about the units for the rate constant and also the order of reaction. I'll see you in the next video. Bye!